In the last session, we learned about Biot-Savart law. In this class, we will take a small problem based on this law to find out the magnetic field. So this law gives us the direction of not the direction, the magnitude of the magnetic field at any point due to a current carrying element. Now you note down this. An element dl equal to dx equal to an element dl equal to dx into I, that is it is along the x direction, unit vector I is placed at the origin and carries a large current I equal to 10 ampere as shown in the figure. As shown in the figure. What is the magnetic field? What is the magnetic field on the y-axis? What is the magnetic field on the y-axis at a distance of at a distance of 0.5 meter? Given dl equal to 1 centimeter. Sorry, not dl, dx is equal to, given dx is equal to 1 centimeter. We'll draw the figure first. I have a small current element which is along the x-axis and placed in the origin. You can draw it as very small element also. At the origin, a small current element is placed, and then we have y-axis, x, y, and this is dx. We have to find out, let us take this point as P, and this point is 0.5 meter from the y-axis, from the origin along the y-axis. An element dl equal to dxi, this is the current element, is placed at the origin and carries a large current I equal to 10 ampere. The current through this is 10 ampere and the direction given is like this. So current direction along the x-axis because it is given dxi. What is the magnetic field on the y-axis at a distance 0.5 meter? Also the current element dx is equal to 1 centimeter. We can use this Biot-Savart law to find out the magnitude first. So from the law we have so according to the law, the magnetic field is given by magnetic field dB is equal to the magnitude of magnetic field dB is equal to mu naught by 4 pi ideal sin theta by r square. Sin theta divided by r square. Now in our case given I is 10 amps, given I is equal to 10 amperes and dL equal to dx equal to 1 centimeter, convert it into meter, that is equal to 10 to the power minus 2 meter. And theta is the angle between R and the current element, DL and R, angle between DL and R. Theta is 90 degree in this case, because our current element is along the x direction and we are finding out the field along the y direction. So the angle between them is 90 degree, therefore sin 90 is 1. Sin 90 is 1. Also we know mu naught by 4 pi is a constant equal to 10 to the power minus 7 Tesla meter per ampere. Now substitute all this in the equation. dB is equal to 10 to the power minus 7 mu naught by 4 pi into I 10 ampere into dL 10 to the power minus 2 divided by 4 pi into R. R is also given, that is 0.5 meter. meter. Point 5 square. So that is 0.25 or 25 into 10 to the power minus 2. Now calculate this. 10 to the power minus 7 into 10 into 10 to the power minus 2 divided by 4 pi into 0.5 square. This will give rise to 4 into 10 to the power minus 8, and the unit of field is Tesla. 4 into 10 to the power minus 8 Tesla. Now the direction is actually perpendicular to the plane containing DL and R. in this case the direction will be along the z-axis. That also you can easily find using the cross product. Here dl in cross r. To find the direction, you can use the cross product dl and r, and we know dl is dx into unit vector I cross r into, and this distance r is along the y direction, so we can take it as y into j because it is along the y direction. Therefore it is equal to y dx or dx into y into I cross j, I cross j, and we know I cross j is z, I cross j is k. K is the unit vector along the z. So it is y into dx into k, unit vector along z. Therefore the direction of the field is along the plus z direction. The direction of the field is along the plus z direction. So here please make a note of this thing, like note. I am just going to remind you about the cyclic property of cross product. We always know I cross j is k. This is called cyclic property of the cross product. I cross j is k, j cross k is I. J cross k is I, and also k cross I is j. K cross I is j. I cross j is k, j cross k is I, and k cross I is j. This is just whenever we want to find out the direction of the magnetic field, we can use this cross product dl into r, dl cross r, so that time it will be useful. Now in this problem the direction is along the positive z direction, and the magnitude of this field is very small, 4 into 10 to the power minus 8. dB is 4 into 10 to the power minus 8 Tesla along plus z direction.